Good morning. I'm sorry that I'm late by 5 minutes behind, and let me just organize myself. Am I started? Check again. YouTubers. Yes, it has been started. Good morning once again, or good afternoon rather, if you are watching this thing in the evening. Yes, sorry about it. I did not send an email this morning. I forgot about it. I was busy actually. I had a lecture, therefore ran out of the lecture and just joined you now. I don't see people on the teams for that reason. Therefore, I didn't invite people. Hopefully, they will join soon. And the good thing is I could see there are viewers on the YouTube. Guys, thank you for joining me. I'm just gonna say hi to indicate that you could chat with me. For today, sorry about once again, I didn't send email. In principle, we will be discussing on, I'm just waiting for the window to display on that side, yes? Yeah, it's there. We will be discussing about PHYV101 plus PHYV101 if time allows. For today's discussion, we will be going on to the tutorial 6 I'm displaying for you, those of you on the YouTube, displaying for you. This is where it is on the Moodle. Therefore, tutorial 6 deals with angular momentum, torque, and then static equilibrium. That's what we are up to. Believe, if not, please, those of you on the YouTube, update me. I have been expecting, or I'm expecting that James must have covered yesterday from question number 1 to 5, and I can go back and check. Question number tutorial 6, question 1 to 4 has been covered yesterday. On the date is not correct though. If not, please let me know. I will go back to it. Therefore, if you question 1 to 4, main question number 1 is basically easy. It's a rigid body. It's a rigid body, as you could see here. Has got a rigid length of 1 meter. The distance between the two L is 1 meter, and joined by two particles, particle number 1 and the particle number 2, with a mass given. The M1 is 4, M2 is 3. At ends, as you could see there, the combined rotated in XY plane about a pivot through the center of the rod. Just basically, this thing is rotating around. And then the question asks, determine the angular momentum of the system. If you are new to this one, please let me know. James must have covered question number 1, question number 2, question number 3, and question number 4. I am planning to start from question number 5. Do you have problem about these questions? If yes, I could assist you. In principle, I've got a memo with me. This sort of memo. Of course, can you see there? I'm waiting until it appears on the YouTubers. Can you see this thing, the one I'm displaying? You see, I've got the memo. If you have got a question, we can go back and discuss about it. Question number 1 is basically here. It is asking you what is, it says determine the angular momentum of the system. Angular momentum of the system. I could see the YouTube is slow, says the internet, the speed is slow, but it's still there though. Just basically what I'm talking here is, if you have a problem with question number 1, question number 2, question number 3, and question number 4, I have got the memo with me. We could discuss, but I'm hoping that this has been covered by James yesterday. However, my intention today is starting from question number 5. Are you there? Let me check again, once again on YouTube, on the Teams, if somebody pop. Not yet, nobody. Therefore, I'm gonna gallop through this question. Question number 5 is the following. As I said, I'll be working from question number 5 on. Therefore, today's tutorial start here. Let me read the question nicely. It says, a particle executes a simple harmonic motion. This is the main information. It executes a simple harmonic motion with an amplitude of 3 centimeters. It undergoes a simple harmonic motion like a simple pendulum, whereby the amplitude, how far it spreads out, and then from equilibrium and up that way, this is the amplitude, is 3 centimeters given. It says, I'm going to bring this one by the way soon. It says, at what position, now this is where we are looking at what position does its speed equal half of its maximum speed? Therefore, the question we're looking for is, at what position on its way, it's a simple harmonic motion, is going in, out, in, out. Think of a simple pendulum that you do in the lab. You go one way, the other way, one way, the other way. At a certain position, let's call it x, its speed equals half of its maximum speed. The speed at position x is half of its maximum speed. Therefore, you have to think two things here. What is the maximum speed of a simple harmonic motion? 1. 2. What is the speed as a function of position of a simple harmonic motion? That if you have those one, it says therefore the speed at a certain position is equals to half of the maximum speed. That's basically what we are up to. Okay. Then for that, I'm gonna bring my tablet in. Where are you? The tablet. Just hold on. I'm gonna come my tablet. Why she complain? Okay. Don't worry. I'm gonna reconnect. Connected. Hello. And my tablet is in. Don't worry, what I'm talking is basically I'm bringing my workout in. She's not. Where is she going? Open. Hello. This is what is happening. It's not allowing. Yes, that is what I want. Yes, this is what I'm looking for. Then, remember what we said? The speed at a certain point x, if this thing, let me just take this thing as like a pendulum. Okay? And then it's undergoing a simple harmonic motion. This is about the origin. This is a maximum displacement A. The maximum, if you're talking about this thing undergoes such a motion, the maximum displacement is relative to the center is, my drawing is bad, that is A. But therefore, what we should be given is a speed at certain point x, omega x, let me call it, must be equals to half of omega max. That's what I'm calling the maximum speed, or if you know speed in terms of v, rather should I use this one? See, because there is no student online, I can't see what I'm, come on, what are you doing? Yeah, come on. Let me rather use v at certain point x, half of v max. How can I do? Therefore, I'm not going to go into the definition. I know that the v square, okay, plus omega square, x square, go back to the derivation if this is difficult for you, but I have seen on your lecture notes or on a Professor Team's video, this is indicated. This must be equals to omega square a square. This is basically by the maximum. Yeah. Then it's given from this expression. I'm gonna put a little bit up from this expression that we know that V max is equals to omega A, where omega is the angular frequency. That's why I delete that one. Let me change the other one to red. And then I was also given V is equals to omega A over 2. This is half. That's the given expression. If you put this one into the whatever we have here, into this expression, therefore, we simply see that the omega A over 2 square, yeah, plus omega square A square must be equals to omega square A square. Just put into that expression. Then you simply see from this expression, you will see, I'm gonna a little bit reduce this thing. I hope you can see. Let me check what you see on the YouTube. Okay, yeah, you could see clearly on the YouTube also. Therefore, I'm just checking up and down inside. Therefore, you could solve for x. You see, from this expression, find that solving for x, that's what we're looking for. At what position as we are looking for, you could simply see that the x square, if you solve for x, you will see x square is equals to 3 over 4a. Yeah, then we know it's given, a is given, you are given that a is equal to 3 centimeter from the given equation. If you put this for, therefore, x must be the position at which you are looking for, it should be plus or minus the square root of 3 over 4a, which is equals to plus or minus, according to my calculation. I could simply see that it's root 3 over 2a, and I put the number, I got about plus or minus 2.60 centimeter. This is a position at which the speed is half of the maximum speed. You see, because I don't have anybody online, especially on Teams, I don't know if this is perceived properly. I'll go back to the question. Those of you who just joined on the YouTube, I'm going through PHYV question 5 to 9, because the other one has been solved. If you're struggling with, let me know. Therefore, I just finished question number 5. But it is displayed there, you could read through. Yeah, question number 6 come in. On this question number 6 is also a simple harmonic motion. I could see the amplitude of a system moving in a simple harmonic motion is doubled. You see, doubled. That's what I'm interested in. Oh, by the way, did I correct? Yeah, the answer is 2.6. That's correct. Number 5, not a problem. It's doubled. We are given that the amplitude is doubled. Determine the change in total energy, the maximum speed, the maximum acceleration, as well as the period. What it's given here is basically, I'm going to pull a bit up. Therefore, what we are talking there is given that the amplitude is doubled from A, now it's go to twice of A. This is what is given. Because of that, this is question number 6 on PHYV101. That's given. What happened to the energy? I think this is quite a very simple expression given, but basically this asks you, do you understand the equations, or do you remember the equations for a simple harmonic motion? If you say so, therefore E, let me change my pen, let me change to blue, come on. Take my blue like that one. Yeah, now change it to blue. And I want to read this. Therefore, if you remember, the energy of a simple harmonic motion, E, is half kx squared. Remember, it's like a spring, is half, k is no k in this case, k a squared, where a is amplitude. And then therefore, if a is double, this implies that I could see that the E2 or E nu must be equals to half of k, the amplitude a is doubled, to a, therefore square. I think this is a very easy one. If you double that one, it's going to be 4 times of E naught. If I call this one E naught. Can you see? Basically what I did here is, okay, therefore it's a 4 into 1 over 2 Ka square. This 1 over 2 Ka square is a given energy from the formula. Then for if you just take the 4 out, if you double the amplitude, you quadruple the energy. It's 4 times of the initial energy. Energy increased by a factor of 4. Does make sense? Let me check if YouTubers are there. Good. At least there are people who liking, saying, I see what you're talking. Thank you. Then let's go. What about the next? What is the next question? The next question is determine the total energy. We got it. The maximum speed. Again, this is basically to say, do you remember the speed? The equation for the speed. I will bring, therefore, B. This is I. Double I is about the speed. I know V max. V max. The maximum speed for such simple harmonic motion is the square root of K by M times A, obvious. This is a square root of K by M times A. No, A is not under square root. Should be careful. The square root of like this. Okay, otherwise it will affect. You'll see. Therefore, if this implies that the new max, V max, new, must be equal to the square root of K by M is constant, obvious, and then the A becomes twice of A. You could see, therefore, the maximum V new, maximum new would be double, twice of V naught. Let me call this one as V naught, even though it is the maximum speed. You happy? If not, you could have asked me. Say, send me email or whatever communication you have. I met this morning a gentleman also, and I understand, guys, during this time you have a class, mathematics, and because you are in engineering, it doesn't mean that you take all the physics course. You have so many others also said computer science, also the other ones, more engineering classes. By now you must be in class. However, when you come back and listen to this video, if you go through and then you find it difficult to understand what I'm talking, or if it doesn't make sense for you, please contact me. We'll work through. Okay? And the next question we wanted to answer is maximum acceleration. Remember, this is also a simple harmonic motion. It starts from 0, and then if you release it, it will start moving, like you pull a spring and then let it go. It's going to oscillate by simple harmonic motion. Forget the resistance. Then there is an acceleration. Therefore, for acceleration, we know that the I must display my tablet. Acceleration must be A max. Again, the maximum of the acceleration is given by formula K over M times the amplitude A. This has been derived in the class. That's why I'm just going in. I don't need to rederive the equations. Therefore, then I will say if A is doubled, you could see that the A new, the maximum acceleration, this is a vector in principle. I'm just careful, careless rather. I'm not putting the vector. It's basically K over M times twice of A, or basically it is twice of the first acceleration A naught. It's also double. The question is what happened. I believe the last one is the period. This is 1 I, the 3 IV. The last one is about the period. But again, the period T, basically this is to remember the equations that we're talking. The period T is, remember, this is a simple harmonic motion, 2 pi L over G for the simple harmonic motion, no, for the pendulum, and there's the square root of M over K for a spring mass system. And therefore, can you see? There is no amplitude associated with it. Therefore, actually the period is constant. Meaning it does not depend on the acceleration. It doesn't depend on the acceleration. Therefore, if I go back to the original question, what is it? Oh, the answers are here actually. He said, determine the change in total energy 4 times, correct. And then the maximum speed, we said it's doubled. Yes, it's doubled. The acceleration, we have found it is doubled. True, it is doubled. And then the period remains unchanged, obvious, because the period is independent of the amplitude. How did I answer this all? Basically by remembering or by knowing the equations of motion for a simple harmonic motion. I wish students are online though to argue with. Now YouTube even slower, but YouTube is not receiving enough video or maintaining a smooth transmission. I believe our internet is not good, yeah. But hopefully you guys through time is gonna feed in. Thank you for liking again for the YouTube. I could see Thank you for that. Maybe let's slowly go. Where are we then? Question number 7. Question number 7. Oh, it says, oh, now, oh, I'm passing it through torque. You see, this is about a torque now. A particle located at a position vector of r is given. The position vector is 1I plus j. I must write this one on my tablet, even though you can't see. Let me give you, I'm going to copy because this is question number 7. R, the position vector is given as I plus j, and the force applied on it, the force is given as 2I plus 3j. It says, acting on it, the torque about the origin. You see, the torque about the origin is, you see, it's kind of confusing you. What does it mean, the torque about the origin? Let me now bring my tablet. This is what it means. If you think of this is a xy coordinate, this is a two-dimensional system, and then the positions of the particle is, if you say the particle is about there in xy coordinate, where x is equals to, this is a position vector r, the y component, if I call this one y, that component x, y is 1, x is also 1. You see it, because it's a 1i plus 1j. Then a force which has got a vector along positive x and y coordinate, therefore the magnitude is 2i. If you call this one is a particle, come on, my tablet is sleepy, this one is, and then if I have got a force acting on it, and the force has got a component actually along 2i, let me call it, this is a force along 2i, we know it is the I component, 2 Newton along x-axis, and then 3 Newton along y-axis. This is 3 Newton, 2 Newton, force is in Newton obviously. And then the question is, what is the torque? For me, it's very, very easy again. The question is, do you know the formula for a torque? The answer should be yes. Tau, which is torque, is defined as R cross F, I believe, yeah? R, the vector R cross the force F. Please check for me this one. It's not F crossed with R. This is wrong. This is negative. Therefore, I believe that is the case. Let me check, because I don't have a student online. I'm going to go into Google and then check the definition of torque. Let me see. Let's check. What is torque? T-O-R-Q-U-E. Equation, in terms of equation, vector also. V-E-C-T-O-R. You see, if you guys, you are online, you would have said that, sir, it's right, it's R cross F. A cross product. I want cross product. C-R-O, cross product. And what does it say? Hey, nobody gave me a very simple torque. It's like R cross, I know it should be R cross F, I know for sure. But how, somebody help me. Yeah, R cross with F. Let me just type silly. Where should I go? Let's see, torque calculator. I'm supposed to stop there. I could see here. Torque is defined as R cross F. I was right in my head, but it's a long time that I thought about it. Therefore, it's R cross F. The question, we know how to define the torque. Therefore, this is a good. This is what I'm gonna use. Not this one. This is wrong. You get a negative if you use F cross R. It must be R first cross F. Then, what's the next then? Remember the analogies that we have been using. I'm gonna make, it's a cross product between two vectors. Remember we said A cross B is as given as a magnitude, or is a determinant way of finding vector calculus. I, J, K. Remember, if the A component of the vectors are, I'm using different, like A1, A2, A3, that of B are B1, B2, and the B3. What do we say? This is equals to, when you find the X component, you delete this one, and then you go B2, what is that? A2, B3, minus, you go that way, backward, A3, B2 along I component. This is I component. and plus the j component is when you find the j component, delete this one. I remember on a book sometimes I go negative, but I always work properly. What I mean properly is I go like this: I, j, and the k. When I work through cross product, therefore I know that I cross j will give me k, j cross k will give me I, and then k cross I will give me j. See, this is a very good to remember. When you go I, j, you get k. When you go j to k, you get I. When you go k to I, you get j. This is positive. The reverse is negative. Therefore, when I'm looking for the j component, I always, you see, I'm here. The j component, I always go from k to I first. That is positive. What it means is, therefore, the j component is the following. I go from A3 from here down to there first. That means A3, B1 minus, I'm going to go now from here to there, opposite. A1, B3 along, not I, along j component. This is a j component plus the last component. The last component is going to be k. Where do I get k? K is actually from I to j. Therefore, when I get the j component, I'm going to erase this one. From where to where I go? From j to I. From that j from I to j rather. From I to j. What it means is, for this component, therefore, for the last component, I go from I to j, meaning I'm going to go from A1, B2 minus A2, B1 in the k component. This is the rule I want you guys must follow. Okay? For a vector cross product. A1, A2, A3, B1, B2, B3. The x component is going to be, you delete the x, that one, A2, B3, A3, B2. The y component this way, the z component that way. We know this. Use this one always. Let's put this one in practice then, according to whatever is given. We are given that the torque is 1 and 1. I'm going to put this one just for the sake of completeness. Now, tau, we know it is R cross F, where R is 1I plus 1J, and then the F is 2I plus 3J. See, therefore, I'm going to use the same concept. I'm going to make now, therefore, my tau, the torque must be equals to I, J, K, and I don't have three components now, therefore I have to start with R first. One, let me change my pen again. The component is R, therefore it's 1, 1, 0, there is no Z component. The force is also 2, 3, and 0, there is no Z component. Am I right? Am I taking the equations properly? Not you. Where is that one? I'm going back to, 2, 3. Yeah, x is 2, y is 3, and fourth force 1, 1. Good, that's correct. Therefore, let's do the operation. Our operation says the torque, therefore, equals to, I'm going for the I component. For the I component, forget this one, and do 1 times 0 is 0, 3 times 0 is 0. I'm going to have 0 along I, plus, when I look for j component, I start with k. 0 times 2 is 0, 0 times 2 is 0, 1 times 0 is 0 along j, plus, when I'm looking along k, now I'm going to go 1 times 3 is going to be 3, minus 1 times 2 is 2 along k. Therefore, the force must be, or the torque must be 3 minus 2 is going to be 1, 1 along k. This should be the correct answer. Let's see if that is the case according to what the equations are given. I would imagine it says 1k Newton meter. Of course, you know what the SI unit of torque is, a Newton meter. The answer is should be this one. Not that, not this, not that, not this. Guys, those of you on the teams, I could not teams. I forgot even about the team. Nobody is on the team because I never invited today. Sorry about it. I'm gonna just even leave the teams. Nobody is joining. Yeah, I left the team. Therefore, those of you on YouTube, you could see we get the appropriate one. Let's check though. I'm sure it's correct. Yeah, it's easy. Therefore, 1K along K Newton meter. Happy? Those of you who just joined on YouTube, we are on a PHYV101 tutorial number 6. Tutorial number 6. This is where on your Moodle, Nelson Mandela University, obvious. Those of you from international, if any, and the questions we go through, and we were on question number 6. Number 7 is finished even. Yeah, isn't it 6? Yeah, 7 is finished. If you have any questions also on YouTube, please. I'm reading also on the chat. I don't see any chat so far. Please ask a question. And there's also you liking. Thank you for liking. Please, guys, you can share if there is a friend somewhere, somehow, to benefit from our discussion. You are welcome to do so. Okay, and are you happy about this particular question? Question number 6? Yes? No? Maybe? I could see those of you on the YouTube, the number is increasing. Good, nice to see. Therefore, let's push. Question number 8. It says, is this thing work out? Yeah, it says a torque can be exerted on a body with a fixed axis of rotation. Okay, then what? A torque can be exerted on a body with a fixed axis of rotation. Okay, only by a centripetal force. Hey, somebody else is saying no. Do you have any? I don't know what you mean. And no. Oh, you mean maybe you're saying I don't have question? I don't know. I'm talking about somebody. Shahret's hair. I hope it is a real name. There it says no. You mean you don't have question or you don't like it? I'm saying, don't you like my presentation? Come on. Okay, I'm also following up. Okay, let's continue then. He says, torque can be exerted on a body with a fixed axis of rotation only by centripetal force. By the way, this is kind of tricky. What does it mean? Let me just bring my... What do you mean then? Centripetal force, you know, the centripetal force... can I make this one a little bit like this? And then my tablet also a little bit like I'm trying to share. Oh, thank you. Questioners, you think you don't understand question number 7. Thank you. Let's go back. I'm happy to go back to you. Thank you for I don't understand number 7. Okay, good. You see, happy to assist you. Let's go back to it then. This was the question. I hope, I don't know, based on the name, I can't say a boy or a girl. But thank you for your question. Let's go back to it. Just read through. It says a particle located at a position vector. The position vector is given. And then the force is also given. And then the question we're looking for was, what is the magnitude and the direction of the torque? This torque. T-O-R-Q-U-E. But I said to you, torque is, I'm going to redo it, this thing, therefore, I said to you, definition, torque is defined as R, the vector R, crossed with the force F. This is definition 101. Happy there? If not, this thing I shouldn't ask you also. You must know this one. Torque is defined as a force perpendicular distance. You are an engineer. If you are from the engineering section, think of you are trying to use a, what is this thing, a screwdriver or kind of something to open. What do? You connect to it and then you apply a force. That R is a arm length of your device, and then you applying a force in a certain direction. Torque is basically a turning effect. You wanted to open a bolt, for example. You want to open and then you put it on it and then you unscrew it. Therefore, that turning effect is what we call torque. TORQUE. Definition is R cross F. We are given that the R is a vector. It is 1 along I plus 1 along J. Okay, I'm hoping that you're watching what I'm doing. Then you are given also that the force is a vector, is 2I plus 3J. Knowing this, and then knowing that one, I also said you need another information. You must know the vector cross product between two vectors. Radius is a vector, force is a vector. What I said to you, this is actually using a determinant way of vector calculus. Put your I, your J, and then K. Is this thing new to you? I hope that, oh yeah, thank you. You said yes, you understand, you are watching. Then I said to you, put your values in. What is the x component of the radius? You must put the radius first. What's the x component? 1. What the y component? 1. What is the z component? 0 along k. It doesn't have any x component, z component. Therefore, I'm going to put 1 there, 1 there, 0 here. And then I go back. What is my force component? What are the components of the force? I'm going to say, oh, okay, it's given along x is 2, along y is 3, along z again is 0k. Because from the given, I don't have anything. Then I'm going to put 2, 3, 0. Now I've made myself ready. The next thing I should be worried is, how do I do a vector cross product? Using this method. I said to you, if you are new to this, please go back to it. To find the x component, you first forget about this one. You can't see what I was almost putting my pencil on this one, but you can't see on on the screen. Remove this component. Forget as if don't see this one. Okay, don't see that one. Then start from that one and multiply this way. The first is that way. What is 1 times 0? It's going to be 0. Second, go that way. What is 0 times 3? 0. Therefore, this is actually 0 minus 0 along I. Plus, when you're doing now the j component, I'm going to remove and come back, by the way. I need this one. It's going to be I 1, 1. When you're doing the z component, let me slowly go through this one. That might be where you saying I don't understand. When you're doing this component, forget about this one. Now, start from the k component. Start from the 0 times 1, which is 0. And I'm going to write it here. 0. And then now do the other one, minus side. 1 times 0 is minus 0 along k. Then the last component, I'm going to again try to clean my mess here. Okay. That is 1. When I'm doing the k component, forget about that component. Where you do go? You go from this way. First do this one. 1 times 3 plus, that is not k. This one is the j component. That was when I was doing the j component. Plus, the k component is coming. 1 times 3 is 3. 1 times 2, this is also 2. 1 times 2, this is what I'm replacing. 1 times 2, the second is that way, minus 2 along k. Then I said this is 0, that is 0, 3 minus 2 is 1, I will go to 1 around k. K is the direction. What about now? Shashi Art? I can't see, I don't know what. Yes, no, now. Are you happy? I'm just waiting until you type yes or no. Basically, I'm waiting for you to respond. What I did here is know that the the torque is a cross product between. I understand. Thank you for that. The torque is a cross product between R cross F. Remember that in formula. And then when you cross a vector cross product, go back to your unit 1 and then practice this one, the IJK vector cross product. Happy? And then we know that the answer is also correct. 1 Newton, answer is correct. And on this side, question number 8 now, it says a torque can be exerted by a body with a fixed axis of rotation. Okay, happy? This is just the general definition. Now it's saying this torque is created by a centripetal force. The question is, what is centripetal force? This is a circular motion. I'm going to bring my stuff. I could not share both screens at once. You remember that about the centripetal force. This, if a particle is undergoing a circular motion, always there is a force that is pulling it backward, centripetal force. You know this one, Fc is always equals to mass times acceleration. That acceleration though, this is Fc, with the center seeking, is also equals to mv squared over r, where r is the radius of that, I'll use small, the radius of the circle on which the particle is moving. The thing is, the force is always center seeking. Thank you also, understand. Oh, thank you guys. Guys on the YouTube, at least there is a good communication. Thank you for that. Let's see now. The radius, this force is, you see, this is Fc. The radius is also in the same direction. You see the problem with the centripetal force. The direction of F and the direction of the radius is the same. Therefore, torque is defined as R cross F. What do we say? It's a, also you need to remember in unit 1 now, this is the magnitude of F, the magnitude of R, not that one, the magnitude of R, that is, this is magnitude of F, magnitude of R sine theta, where theta is the angle between F and R. In this case, by the way, let's even discuss about the general condition. To have a maximum torque, torque is maximum, I will say torque is max if theta is equal to 90 degree, because sine 90 is 1. Torque is the minimum, there is no torque. Torque tau is mean if theta is equals to 0 degree. Because you pushing or you pulling, there is no turning effect if the angle is 0. However, if you see my video now on those of on YouTube, if you want to turn something, you have to use a perpendicular force. That is exactly what these equations are talking. The force is not the force. A torque is maximum if the angle between the direction of the force and the direction of the distance or the arm length is 90 degrees. A torque is a minimum if it is in the same direction. Therefore, based on this one, for the centripetal force, the angle is the direction of F and direction of R is the same, meaning theta is 0 degree. Therefore, centripetal force has not caused any torque. The answer, therefore, here, if you go back to this question, a torque can be exerted on a body with a fixed axis of rotation only by centripetal force. That is wrong, actually. This centripetal force has no torque, has no effect of turning it. Therefore, choice number 1 is not correct. 2 says only by a force directed radially outward. This is opposite of that one. If you come to my definition here, this is centrifugal force now. Radially out means the force is now outward. Anyways, in that case, the angle is here, the angle is 90 degree in the first case. Case 1, which is F centripetal, theta is 0 degree, sine 0 degree is 0, therefore torque is min. We said it is minimum. In the second case, if it is the centrifugal force, if I call it, the theta is 180 degrees. The radial is inward, the force is outward, the angle is 180 degrees, the sine is anyways 0. Sine of 180 degrees 0, therefore there is no torque. Meaning this one also does not cause any force, any torque. These two are wrong, we already know. Only tangential force, I like this one. Tangential, what it means? If I bring back to my tablet again, then now this means anything that undergo a circular motion, my drawing is bad, it has got a tangential force, F tangential. You see the radial, you see the angle between them is 90 degrees. This is actually a maximum torque. Tau is max because the angle between them is 90 degrees. This implies that answer is correct. However, where am I? Not on this one. I want to go there. However, why it says only? It's not only tangential force that causes any force that is actually, this is true, but what makes it wrong is it's not going to be only tangential force. What I mean is here, I've actually answered it here. Because the torque is given by magnitude of the force, magnitude of the distance, sine theta, any angle between 0 to 90 degree can do. Or I could say any angle except 0 and 180 degree. Rather, that's a correct answer. Any force or that is directed in a certain direction, whereby the angle between the direction of the force and the direction of the radial distance is different from 0 and 180 degree, have got a torque, has got an effect of torque. Therefore, based on this definition, that this thing would have been true, but it's not only. I would be happy if this one would have said that maximum force is because of a tangential force. I will take that one as a real. Let's say D. Only by a force with a component directly radial outward. That is completely wrong. It's the same as to that one. By a force not pointing directly toward or away from the axis of rotation. You see, this is a correct one for me. The correct one therefore should be E. Any force that is not, the angle shouldn't be 0 or the angle shouldn't be 180 degrees. Other than that, anything can cause a torque, a turning effect. But it is maximum when it is tangential force. It's a minimum when it is 0 and 180 degrees. I'm talking about the angle. I believe E should be the correct answer. Let's check. Should be the case. Yep, and it says, but it's by any force not perpendicular or not parallel or anti-parallel. Parallel when 0 is directing inward, anti-parallel outward in this case. Do you have any? I'm kind of having a cold, or you guys, there is kind of a running flu around and it's difficult to run away from it, but I'm recovering though. I'm gonna hold on there, guys. Abe and art. Are you happy with the definition of the torque that I just went through about question number 8? Thumb up, thumb down. Or you say yes, means yes, it's okay. If you say no, I'll repeat. Are you right there? Those of you who will be listening to our conversation after it is uploaded on Moodle, by the way, it's right. Not uploaded on Moodle, it's going to be on a YouTube. We are live on YouTube, therefore you're going to watch it there. If you find it difficult, please contact me again. My guys or my girls down there, are you okay with it? Question number 8. Is it lunch time? Almost 1. Hello. No comment. Talking, I don't know. Guys, are you alright then? If you're not, please just go back to it. I'm just gonna repeat a little bit. A force by centripetal does not make any torque because the angle between the direction of centripetal force. Thank you, Abe. And you said yes, it's good. B, only force by directed radial outward. This and this doesn't have any torque at all. The other one has got a maximum force, but it shouldn't be only. This one, D, is basically talking about that one, not true. E is a correct choice. Thank you for understanding. You say yes. Number 9. This number 9 would have helped me. Question number 8 actually. I wish I would have done question number 9 before number 8. Check here. Consider a force F applied to a cylinder as shown below. It's kind of a cylinder. It says, which cases result in the non-zero torque? Guys, let me give you a chance. About the central axis of the cylinder. Think of this as a cylinder, like going away from me, and then the radius is down there. And if you see my cursor on the screen, this is the radial distance, and this is force. Which one, or you could have multiple choice, is it true? Which can result in non-zero torque? Which one do you say? A, B, C, D, or E? Give me just a comment. Which one do you think is non-zero torque? Or basically, which one produces a torque? Number A? Do you think number B? Number C? E or D? Basically, F and E kind of the same that we discussed. Centripetal, centrifugal. F, tangential. I'm giving you a hint. And that one is a little bit of the axis. That one, almost that one, but in a certain angle. Which one produces non-zero torque then? What will be your answer? I wish there is a multiple multiple select one. It says we are only given to choose one. Which one do you think is correct? Super, thank you. I was expecting you to pop it up. You say, hey, good. Yes, it is you. Good. Then I 100% agree with you. You said A, I believe A. Because basically this is what we just did. This is the maximum is actually that one. By the way, I don't like this question per se. That is true. This is a maximum torque. I could edit this one if it is me. Which case result is in a maximum torque, not non-zero force. This one is also non-zero. Why not? Why it is producing zero? It has got a little bit of you see. Let me come. That one is correct. I agree with you, but that is completely wrong because the direction of the force is down. The direction of the radial distance is also down. The angle between the force and the radius is 0 degree. That can produces no torque. This is almost the same. E is also, no, D is opposite of B. They're same. Centripetal, centrifugal forces. Agree with it. However, F and E do produce a torque, but the magnitude is small. Ask me why. Let me bring my tablet in. In the case of this one, in the case of, which one is this? Let's concentrate on C. You see if I make the center there, it's like this one. This is my circle, the drawing is poor, the radius is something, this is the middle of this thing, I'm talking about that's the middle, and then a little bit off, this is the force. Okay, that force has got a distance, this a small r. It's not the whole radius, capital R, it has got this one. Therefore, the torque due to this one is actually that force R, that small r, very, very small, crossed with the force. Therefore, the angle is not going to be there. The angle is 90 actually. Therefore, the magnitude of R, the magnitude of the force F, sine 90 degree because it's perpendicular, it has got. This is therefore magnitude of R, magnitude of F. But because of the fact that I'm going back to that display, where is this one? You see, it's off axis. It's not at the middle. If it were at the middle, I would say it's 0. Check this one also. It's not acting horizontally. It's off. If this is the center, then I could also come back to my tablet. What I mean there is, in this case, this is a circle. The force is acting at a certain point. If I say again, this is my radius R, therefore this force has got a component if at certain angle theta. It's just at an angle theta. It actually has got a torque, which is F magnitude of the force, magnitude of R sine theta, where that theta is the component of the angle or the force. And that radius is also, it's not the overall radius. I'm going to make this one capital R. That is a small radius R. Then for my conclusion here is, yes, the correct answer should be A, according to what is given. I could check it. Should be. Yeah, A. However, this question not correct. It need addition. Not non-zero. This is supposed to say a maximum torque. Then A would be the perfect answer. As it is though, it says select one. If it is given, select multiple selections is possible. I could go to, where is that? C and E is also correct. It is non-zero force, but it's not a maximum force. You agree with me? Kwabe? Pesile? It's also you who has been with me, that's why I'm calling your name. The others who just joined the YouTube, guys, welcome. But we spent the last 1 hour talking on a PHYV tutorial 6, and that's where we are. And do you agree with me? This question need kind of a little bit of addition, which case result in a maximum torque. The correct answer is A. As it is, A, C, and E indeed produces a non-zero torque, but the maximum one is A. Do you agree with me? If no, can we argue? By the way, this is how far my schedule. I'm gonna bring this. Where is that one? Just here. According to what James sent me, this tutorial is from question number. Yeah, yes, sir. Thank you for the. I'm going back to the comment. Thank you. You agree with me that this question is not good. This is basically we wanted to discuss question number 5 to question number 9. That's where we are. I'm done. But let me give you one extra because you are here. Let's work through this one. Is a static equilibrium. Just to give you this static equilibrium also involve a torque. That's what I just wanted. Even though Tariki Arnold will be taking over from this question tomorrow. Let's work through this one because I've kind of had a bit of time to spare. It says a horizontal uniform metric stick. You see A is the meaning. It has got 1 meter. A horizontal uniform metric stick supported at 50 centimeter mark has a mass of 0.5 kilogram hanging from its 20 centimeter mark, and then a 30 kilogram mass hanging from it at 60 centimeter mark. Determines the position of the metric stick at which one would hang a third mass given mass m in kilogram to keep the metric stick balanced. This is also a kind of rotational per se, but it's a static equilibrium. Let me put what it says. How can I bring my tablet there? Whilst you're busy reading, let me draw what it says, and I will bring my tablet back. It's a metric stick, 1 meter. It's a metric stick. I'm gonna put it big. This is 1 meter. You don't see what I'm drawing, you will see soon. It is supported at 50 centimeter, has mass of Oh, okay, means halfway. Its mass is gonna be 0.5. At the middle, this is 50 centimeter. You don't see what I'm drawing, I'm just reading. A horizontal uniform metric stick supported at 50 centimeter has a mass of 0.5 centimeter hanging from it at 20 centimeter mark end. Okay, I'm going to use red. At 20 centimeter mark 0.3 kilogram. This one is, let me call it this side, 20 centimeter, has got a mass hanging on it is 0.3. And 0. What am I reading properly? This one, a horizontal uniform metric stick supported at 50 centimeter mark has a mass of this much hanging from it at 20 centimeter. Okay, and then this much. I was wrong. My drawing is wrong. You will see. I better bring it here so that we work together. This is what I was drawing. I'm gonna restart. You could see now what I'm doing there. Instead of making it 3D, even I'm gonna make a straight line. See what I'm doing now? It's a metric stick. Let's say 1 meter. The whole length is 1 meter. 100 centimeter. Because the other ones are given. It's a horizontal metric stick supported at 50 centimeter mark. Supported. There is a support at 50 centimeter. This is you have kind of something you balancing on it at 50 centimeters. This distance is obvious. It's halfway. That distance is 50 centimeter up to there. From one end to the center. Has a mass of 0.5 kilogram hanging from it is 20 centimeter. Let's start there. There is a mass at how far? 20 centimeter. Let's say on this side. Oh, I don't want that pen. I want this pen. This one 20 centimeter. There is a mass hanging on it, which has a mass of 0.5 kilogram. Down its mass 0.5 kilogram from it, and the 20 centimeter at 20 centimeter mark, and 0.3 mass hanging from it at 60 centimeter. If this is which way I go? 60 centimeter should be, let's say this is 0. That drawing also, you see, I haven't read this question, I'm just jumping in. I must be careful. Where is the 0 measuring? That's why 60 is going to be difficult. This is 20. Then I know this is 20 centimeter is 0.5 kg. Then the 60 is going to be here. Because this is 50, it passed it, it's going to be down. What is this? And 0.3 kilogram. Now it says determine the position on the metric stick at which one would hang a third mass M. A third mass M to keep the metric stick balanced. By the way, easy. Then you could say, where is the question? Where do you put? Are you going to put here? Let me change another pen. Like, I don't like the green. Are you going to put it here? Let's call it here. Or are you going to put it here? Where do you think you're going to put? But it is balanced. It's balanced at the middle. Therefore, the weight is not in use. A metric stick, a horizontal metric stick supported at the 50 centimeter part. The weight is killed. The weight of the metric stick is useless. It doesn't make any torque because it's supported at the center. and has a mass of 0.5 kilogram hanging from it at 20 centimeter. And a 0.3 kilogram mass hanging from it at 60 centimeter. Determine the position of the metric stick at which one would hang a third mass M, as opposed to this mass supposed to be given, I believe. Something is wrong there. M, to keep the metric stick in balance. Basically, let's do the following. What you should be doing is, this is to do with a torque. It says for this thing to be, like, let me maximize now my view. For this thing to be at equilibrium, it's not going to fall that way or this way. Counterclockwise torque, let's say the torque that pushes this thing to rotate this way is clockwise torque, tau clockwise, and then the one that pulls this way is counterclockwise torque, is the same. For this thing to be balanced, remember we said torque is R cross F, or the magnitude of F, the magnitude of R sine theta. This must balance. How many torques do you see here? Now let me clear here. This one is just equation though. The question is, where do you put? On this side or on that side? And then the next you ask yourself is, where is the axis of rotation? The axis of rotation is actually here, at the center, at the middle. It's going to rotate about this. I almost deleted. It rotates about this axis of rotation. What is torque clockwise then? This guy is going to cause this one to rotate that way. Then I will say tau clockwise must be the distance of the object from the axis of rotation. In this case, from here all the way to here, which is, if this is 20 centimeters, this should be 30 centimeters. Therefore, I will say the magnitude is 3 centimeters. Don't worry about that centimeter, because it's going to be the same on the other side, times the magnitude of the force. The force is mass times the gravity. The mass is 0.5. Also, this one is 0.5 is half, 3 over 2 g, acceleration due to gravity, in centimeter in Newton. I'm just going to keep it. Don't worry about the unit. What about clockwise torque? What is this guy doing? The 0.3 kilogram. What is the distance? The distance, of course, you could see, if from there to here is 60, that distance should be 10 centimeters. Therefore, this one is 10 centimeters. I'll say tau counterclockwise must be equal to the distance, which is 1 centimeter, times the mass, which is 3 over 10, 0.3, times mass times gravity is g, is also there. You see which one is big. And if you see here, what I could easily see is, this is going to be 3g over 10, and then this one is going to be 3g over 2. Forget about the unit, because I'm comparing. Therefore, I could easily see that which side is going to be, this one is less. This is less. Therefore, tau counterclockwise is less than tau clockwise. I should put this object. Therefore, the conclusion is therefore, if this is a metric stick, if it is supported there, the other y is 0.5, mass is going to be sitting there. The other one is here, 0.3 kilogram is sitting there, and then supported here. I would imagine, because the counterclockwise torque is smaller, I'll put it on this side. I don't know that position. I'm going to call this one as x. Okay? With this assumption, therefore, that mass m, if you have got m here, mg, the mass times gravity, times x, because that's the distance. By the way, the angle is always 90 degrees. Remember, the force is down, The radius is that way. The angle between them is 90 degree. I forgot about that one. Even plus mass times the gravity, which is 0.3 g times the distance is 1 centimeter, must be equals to 0.5 g. This is mass times gravity times the distance that we said. If this thing is 20 centimeters, that is 30 centimeters from the axis of rotation, 3 centimeters. From this though, I don't know. X is not given, M is not given. I can't solve. I still find this equation is not nice, or it's not edited properly. You see, that M must be a value. Or maybe that one. Let's solve for, but how can I solve? I don't know. Let's solve. Can I solve for anything from this equation? M is not known, X is not known. I could see here the gravity could disappear from everywhere. Then mx, the mass m times x must be equals to 0.5 times 3 minus 0.3 times 1. Or it's basically, what is 0.5 times 3? 0.15? Yeah. 1.5 rather. 1.5 minus 0.3. Therefore, I don't know. M is not known, X is not known, I can't tell. But I could tell from the given equation, it must be, that mass must be hung on the side where the 0.3 kilogram mass is hanging. Sorry about my cough, and I believe I'm getting tired. Guys, I will speak to Arnold also, and that he has to edit this equation to come up with. I don't know which one is the correct answer. Let's just click on something, and just the reality is M or X should be given. What else could I have done? Determine the position on the metric stick at which one would hang a third mass M kilogram to keep the metric stick hanging. No, the M must be given for sure. If I'm determining the position, M must be given. That's my final answer. Thank you. And just to give you, Arnold will work through the remaining one tomorrow, but I could talk you through, but it's either though. I'm happy there are a lot of questions here. Please work through. Try yourself, and then we will give you the memo basically. Please, I'll give you 2, 3, not 2, maximum 1 minute. Do you have any question for me today before I sign out? Otherwise, I'm as good as done for today. Thank you for joining me on the YouTube. The Teams, again, I didn't send an email this morning. I'm sure nobody is there. I'm hoping that nobody is there. Just let me check once again. Yeah, nobody is there. Therefore, no worries. I didn't send an email. That's why I don't have any on the YouTube. Used it to be better. Guys, those of you on the YouTube, thank you for a day. Please work through. I don't see any comment up to now on the chat. Going back to YouTube, in case if anybody has said anything. Okay, it looks like no question. Thank you for coming in, and then see you next week.